Let's look at how we can use the periodic table to get the order of increasing energy of those sublevels. Let me see if I can zoom out a little bit. Okay, so the periodic table actually contains the order of increasing energy of the sublevels. And what we have to remember is that these two columns right here are what we call the S block. Okay, so that's the S block. Helium is also in the S block. This section down here is the D block. Over here we have the P block. Everything apart from helium. Okay, so helium is actually the S block. And then down here we have the F block. I'm going to label it at the bottom because it's hard to see. Okay, so these are our F block elements. Okay. And if we recall, the number of valence electrons in a particular atom is equal to the period number. So if you're in period 1, then you have valence electrons in n equals 1. If you're in period 2, you have valence electrons in n equals 2, period 3, n equals 3, etc. Also, the A group number is equal to the number of valence electrons in a particular element. So we can get the electron configuration simply by reading the periodic table left to right. So for example, say we were going to write sodium's electron configuration. We just did it in the last video. Let's try and do it again using the periodic table. Okay, so we're going to start first period S block and we just count squares. So it's 1s, 2. Remember, helium should be in the S block. Then second period, 2s, 2. 2p, 1, 2, 3, 4, 5, 6. And then 3s, 1. Okay, so first period S block, 1s, 2. Second period S block, 2s, 2. Second period P block, 2p, 6. Third period S block, 3s, 1. So if you look at the notes you took in the last video, you'll see that it was the same, right? We got the same electron configuration simply by reading left to right. What you have to remember if you're using the periodic table to get that order is that the D block, the value of n for the D block is the period number minus 1. So this is 4s2 and then we have 3d10. Okay, and then back to 4p6. And the F block is the period number minus 2. So this is 6s, and then we have 4f, 7s, and then this is 5f. Okay? Notice how convenient is that? The number of columns in each block is 2, 6, 10, and 14 respectively, which, if you remember, are the numbers that we calculated in our first video for the maximum number of electrons per sublevel. So if you forget those numbers, 2, 6, 10, and 14, you can just get them from the periodic table. And this order of increasing energy we also get by reading left to right on the periodic table. So let's pick another element. Let's do bromine. Okay, bromine's all the way over here. So let's start at the beginning and write its electron configuration. So first period S block, 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 6, 4s, 2. Now subtract 1 from 4, 3d, 10, back to 4, 4p, 5, and we're done. The great thing about using the periodic table is it really helps when you're writing the noble gas core configuration. Instead of starting at 1, you can just start at the noble gas above your element. So for example, you could just read argon, 4s2, 3d10, 4p, 5. And we're done.